Hello students, this is Solvit Grade 12 Mathematics for Ethiopian University Entrance Examination in English. The video is part 3. We have already dealt with part 2, and today let us begin from where we stopped last time. Let us begin by starting our today's lesson by solving question number 5. Question number 5. Here, question number 5 says, which one of the following is an arithmetic sequence? In grade 12 mathematics about series and the sequence, the simplest question which might appear on the entrance examination is such kind. Which one of the following is an arithmetic sequence, or which one of the following is a geometric sequence? Now here, as you can see, in A it says 3, 5, 7, 9, 11 and so on, and in B as you can see 3, 6, 12 and so on, and in C minus 3, 6, minus 9, 12, minus 15, and in D it is 1, 3, 6, 10 and 15. How can we identify these sequences as whether these sequences are arithmetic or geometric or neither? The point is that by definition we say an arithmetic sequence is a sequence in which the difference between any two consecutive or successive terms is constant, and that constant we say is a common difference. Now let us check whether this satisfies these sequences, which are here indicated in the 4 choices, satisfies the given definition about the arithmetic sequence. Let us begin with A. Here, for this sequence to be an arithmetic, the difference between the successive terms, which means 3 and 5, 5 and 7, 7 and 9, and 9 and 11 and so on, if it gives us constant number, then we say that is an arithmetic sequence. Let us try. What is 5 minus 3? 5 minus 3 is 2. Here, as you can see, 5 minus 3 is 2, 5 minus 3 is 2, and also 7 minus consider that suppose that is actually 2. Suppose this is 2, and similarly the difference between 7 and 5 is also 2, and again in the same manner the difference between 9 and 7 is also 2, and the difference between 11 and 9 is also 2, and therefore our common difference D is equal to 2. This sequence fulfills the definition of an arithmetic sequence as we defined, and therefore the answer should be, without going any further, we can answer this one, unless in our choice all of the above or something. We don't need to check any other. Here in B, for example, 6 minus 3 gives us 3, but 12 minus 6 gives us 6, which is 3 is not equal to 6, and therefore this cannot be an arithmetic sequence. And similarly in C, 6 minus 3 gives us 9, and minus 9 minus 6 gives us minus 15, and therefore the two numbers are not constant, are not the same. And also in D, 3 minus 1 is 2, and 6 minus 3 is 3, and therefore 2 is not equal to 3, and this is also rejected. Here the 3 of them are rejected. They are not an arithmetic sequence. Here, as you can see here in solution, 5 minus 3, 2 and 7 minus 5, it is 2. 9 minus 7, it is equal to 2. 11 minus 9, it is equal to 2, and therefore I am sorry, here the answer here it says it is D, but it is A. Here it is already written here, therefore the answer is A. This is the simplest example that might be appeared, or that can be appeared on the entrance examination. Let us go to the next example, the next question again. The next question number 6. Question number 6. Here it says, a certain meeting hall has 20 rows of seats. There are 20 seats in the first row, 22 seats in the second row, 24 seats in the third row, and so on. How many seats are there on the last, which means 20th row of the hall? Here, to understand this, suppose there is a hall. According to this one, it is a meeting hall. Now on the first row, it says on the first row, let us draw like this one, a straight line. Actually, here is, suppose that this is a row. There are 20 seats on the first row, and again on the second row, again suppose this is also a straight line, and there are 22 seats, and on the third row there are, as you can see, there are 24 seats. If this continues until the rows reach 20 to the final rows, is said to be the AN rows, or A20. Let us denote A20 by this one, A20. The question says how many seats are there on the last, which is 20th row of the whole. That is what the question says. Now observe that on the first row there are 20 seats, on the second 22, 24, and the next we can guess also it is simply 26, 28, and so on. This sequence forms an arithmetic sequence, because the second term was obtained by adding 2 on the first term, and the third term is obtained by adding 2 on the second term, and so on. Here the second is 22, the third term is also the number of seats on the third row is 24, and we can guess because this can form an arithmetic sequence, and therefore the common difference is simply 2, and therefore we can guess the next one is 26, the fourth term, or the fourth row has 26 seats, and the fifth row do have 28 seats, and so on up to the 20th row, which we are going to find. Now here, remember, this is an arithmetic sequence. If we say an arithmetic sequence with the first term A1, the first term is 20, and the common difference is 2, and therefore we apply the nth term, or the general term of the arithmetic sequence. This is 2. Okay, we say the general term of an arithmetic sequence is denoted by an is equal to a1, the first term, which means the first term, plus n minus 1 times d. That is how we define the nth term of an arithmetic sequence. We already have seen this one in the first part of the video. Now A20 means what is the last term? The last term, our n in this case is 20, and therefore the number of seats in the 20th row, or the last row in this case, is nothing but just replace A1 by the given number, which is 20. The first row has this much seats, and our n is also, it is 20. Subtract 20 here, 1 from 20, and multiplied by our D, we already obtained D, which is 2. Z, perform the operation in the bracket first, and then we will get the following. Here is 20, the first term, plus, say the first term, times 20 minus 1 is 19. Then 19 must be multiplied by 2 here, as you can see, and then the result is going to be as follows. A20, this implies A20 is equal to here the first term, which is 20, plus 2 times 19 means it is 38, plus 38. Now add 38 on this one, and the result is going to be 58. That is the answer, the right answer. Therefore, on the last row, or the 20th row, there are 58 seats are there. 58 seats are there, and therefore our answer is C in this case. Suppose if you are asked this here, assume that this question appears or repeated this year, and if it says how many seats are there, if on the first row there are 20 seats, on the second 22, on the third 24, and so on, how many seats are there? Now we already know that the following. We already know the first term, A1, which is 20, and the common difference, or I mean just leave the common difference in this case actually, because we have the last term, and the A20, the last term A20 is also, it is obtained, and it is equal to 58. And therefore, using this information only, then we can find the number of seats, the total number of seats in the meeting hall. Here, you know that the sum of the first n terms of an arithmetic sequence can be given as n over 2 times the first term and the last term, which means a1 plus an. That is what we know. Or this formula can be helpful if and only if we know the last term and the first term. But if we don't know the last term, but given the first term and the common difference, then we apply another formula. And therefore here the total S20, the total, because there are 20 rows, therefore our n should be 20, and therefore just S20 means 20 over 2 the total number of seats will be this much. Our A1, we have 20, and our A20, which is the final or the last term, is 58. Add 58 and the 20, and then multiply the result by this one, 20 over 2. Now the sum of these two numbers is 78, and again when 20 is divided by 2, it is 10. Let us put somewhere here, and therefore it is 10 times, then the operation in the bracket is going, it gives us this much, which is 78, and then multiply 78 by 10 gives us 780. Therefore the total number of seats in the hall is, suppose this is 8, is this much, 780, this much. That is if you will be asked this year the number of seats. But for this particular example or question, the answer is 58, because we were asked the last term or the 20th term, the number of seats on the final row, and therefore that is simply 58. But in case we are asked to find the total number of seats, then we must apply the sum here, as you can see. Okay, now let us turn to question number 7. Question number 7. Let us see question number 7. Question number 7, it says, if an is a general term, an in braces is an arithmetic sequence with the first term a1 is equal to 5 and the fifth term a5 is equal to 21, then the partial sum, here sigma notation, this is sigma notation, the summation, it is read as the summation of n running from 1 up to 20, an is equal to, that is what the question says. Now the first thing is to identify the given, what are given and what is required. Here, as you can see, a1, our a1 is given, a1 is 5, the first term is 5, the first term is 5, and again a5 is also, it is given, the fifth term is said to be 21, and we are also told that an is an arithmetic sequence. An is an arithmetic sequence. Therefore, this sigma notation gives us the following. Our n is running from 1 up to infinity. I mean up to 20. And here we have the general term, call this one b20, an. This means in mathematics it is equal to the first term a1, when our n is 1, then we get a1, plus when our n is 2, it is a2, and when our n is 3, it is a3 added with this one. But now no need to write, make 3 dots and then plus, and the final one, when our n is 20, then we have a20 here. This partial sum is an arithmetic sum. It is an arithmetic sum, and therefore to find an arithmetic sum, we know that Sn, an arithmetic sum, the sum of the first n terms of an arithmetic sum is n over 2. We have already seen one of the formula on previous example. 2 times a1 and plus n minus 1 times the common difference d, n minus 1 times d. This must be multiplied by d. Now what is missing? Students, when we are dealing with such type of examples, the first thing is just put the formula as such and observe what is missing, what needs to be obtained. What needs to be obtained must be what needs to be obtained, what is missing. Now here, our n, we have n, which is 20, the final term. There are 20 terms here, therefore we know our n, it is given, and also we know the first term a1 is also given, it is 5, and then what is missing here? The common difference is missing. Then how can we get common difference? It is simple. Use this one. We say this is 5, actually this is 5. I am sorry for not writing it before. Now we can obtain the common difference from this one. using the general terms of the sequence, a5 means it is equal to a1, which is 5, plus n minus 1 times d. 5 minus 1 times d means it is simply 4d. It is 4d. And then put like this one, 4d. We know a5 is 21. 21 is equal to, again, we know a1, it is given, it is 5. And then add this thing with 4d, where d is a common difference. D is the common difference, or d is a common difference. And then collect the number on one side. Let us collect the number on the left side. Here 21. Then if we move 5 to the left, then it becomes minus 5, since it is positive to the right, and this is equal to 4d only. Now to obtain d, what we have to do is we need to eliminate this 4. We need to perform some operation, but let us see that one. This implies, let us put this one here, this implies 21 minus 5 means it is 16. 16 is equal to 4d. 16 is equal to 4d. This is simple calculation, actually. Simple calculation. Now here, to find d, the d can be here 16 over 14 over 4 over 4. Then this is 16 over 4. 16 over 4, which is equal to 4. Now we obtain also d. We get d. The common difference. What is left then? Just to calculate this sum. This sum is exactly equal to this one, a1, a2, the sum of a1, a2, a3 up to a20. And this sum is in arithmetic sequence. Again, this sum is equal to n over 2 times a1 plus n minus 1 times d. We have a1, we have n, we have d. Therefore that sum is equal to, here our n is 20, s20 is equal to, just put it like this one, 20 over 2 divided by, here the divided by, 20 divided by 2, into, again, 2 times a1. Our a1 is 5. 2 times 5 gives us 10. And also here, our n is 20. 20 minus 1 is 19. 19 times, also here our d is equal to, put it in some bracket or use multiplication sign. This is 4. Just put it, this one in bracket, and also the bigger bracket. And therefore this thing becomes, again, these numbers becomes 10. When 20 divided by 2, it gives us 10. And 10 plus 19 times 4 means it is 76. This is 76. The sum of 10 and 76 gives us 86. 10. The sum of this one is 86, we say, times 86. When 10 is multiplied by 86, then the result is going to be 860. What does this 860 mean? It is nothing, but it is simply the summation of n running from 1 up to 20, an, where an is a general term for an arithmetic sequence. Therefore this sum gives us 860. Therefore our answer is C. Our answer is, call it C. Okay, Good. What is C? C is 800. I'm sorry. Okay, 800. Let us call this one. Let us delete this one. We say the sum. This sum gives us this one. Our answer is 860. Okay, let us proceed to the next one. Question number 8. Actually, this question formally was done here. As you can see, A1 is equal to 5, A5 is equal to 21. First, we need to find the common difference D using A1 and A5. To find D, then use AN as the general term. AN is equal to A1 plus N minus 1 times D. And then here we have A5, which is 21, and A1, which is 5, and the 5 minus 1, which is 4. 4 times D gives us this one. Here is 4. And also again, the first n terms of an arithmetic progression is given by this one. We have everything here, all of the variables here, and simply insert each variable or substitute numbers for each variable, and then you will get this one. Okay, next let us see question number 8. Question number 8 says as follows. Pardon me, please. Question number 8. It says, in an arithmetic sequence, the sum of the first term, the first 6 terms, is twice the sum of the second and the 7th terms. The 10th term exceeds 2/3 of the 20th term by 23. Which of the following statement is not true about the sequence? Not true. Which one of the following is not true about the sequence? Now let us change these statements or these sentences first in mathematical formula, or let us formulate this one, and also let us formulate these two, these statements as well. Here in choice A, it says the first term is 3. Don't forget the question. And in B, it says its common difference is -6. And in C, the n plus 1th term is 3 plus 6n. The sum of the first 12 terms is -60, which means 360. Now observe these two. Let us compare B and C. If our common difference is -6, then the n plus 1th term cannot be 3 plus 6n. It must be equal to 3 minus 6n. Therefore, one of the two must be false. One of the two must be not true. Okay, let us see anyway. In an arithmetic sequence, the sum of the first 6 terms is 6. This means it is S6. Our S6, the first 6 terms, the sum of the first 6 terms is equal to twice of the second term and the 7th term. What does that mean? Here, how can we formulate? Just like this one. A2 plus A7. These are the second and the 7th term respectively. Then we formulate actually these statements. The sum of the first 6 terms is twice the sum of the second and the 7th term. This sentence can be formulated as such. And similarly, it says, we have another information here. The 10th term exceeds 2/3 of the 20th term by 23. What does that mean? Here, the 10th term means A10 in an arithmetic sequence, because our sequence is arithmetic sequence. A10 is equal to exceeds the 2/3 of the 20th term, which means 2 over 3 of A20 by 23, means it can be written as such, plus just add here 23, because this term exceeds 2/3 of this one, the 20th term by 23. Right as such. Now we formulate. The statement is converted in mathematical equation. We formulate it. From these two, we can find something. We can find the answer for each of this one. From these two, using these two, then we can find whether this is true or not, or whether this one is true or not, and so on. Now here, by default, we know the sum of the first n terms of the sequence S6 always equal to S6 is always equal to 6 over n over 2, 6 over 2 times 6 over 2 times 2 times the first term A1 and n minus 1 times d, which means 6 minus 1 times d. 6 minus 1 6 minus 1 times d. 6 minus 1 times d. We know this thing. This is d, the common difference. We have also S6 written as such, and also S6 as 2 times A1 the first term, I mean A2 the second term, and plus A7. We will combine this one. From these two, we can find A1 and the D. We can find the relationship between A1 and the D. Let us see. Here, observe this one, which I already calculated here. I already solved it here. Here S6 we say 2 times A2 plus A7, and A10 is equal to 2 over 3 A20 plus 23. Here S6 is equal to 2 times A2 plus A7, means 2 times our A2. Our A2 is obtained. A2 is the second term in an arithmetic progression, is obtained by adding the common difference on the first term. A1 plus D. By adding. And also the seventh term can be obtained by using the general formula. Actually, the nth term of the sequence, the arithmetic sequence, the seventh term also equal to the first term plus 6 times the common difference. 6 times the common difference. Where does this 6 comes from? It is from the general formula, from the general term of an arithmetic sequence, which says n minus 1 times d. What's our n? It is 7. 7 minus 1 gives us 6. Therefore, write 6 here and the d. And therefore, now in A2, replace A2 by this expression. A2 by this expression. A1 plus d. And similarly again, replace A7 by this expression. A1 plus 6d. Then add similar terms. Add the same terms here, similar terms here, which is our similar term in this case is A1 and A1. D and the 6d are also similar terms, and A1 plus A1 gives us 2A1, and the 1d plus 6d gives us 7d, and therefore from this relation we will get this one. S6 is equal to 2 times 2A1 plus 7d. Note that these two multiplies both 2A1 and 7d, and call it equation 1. Call it equation 1. And also from the sum, we already write here, from this sum we know that our Sn is equal to n over 2 A1 plus n minus 1 times d, and the sum of the first 6 terms gives us S6 is equal to 6 over 2 2a1 plus 6 minus 1 times d. This gives us 6 divided by 2 gives us 3, and therefore here we have 2a1 plus 6 minus 1 gives us 5 multiplied by d, the common difference, and then call this one be equation number 2. Then combine these two. From 1 and 2 we have our 2, this one is 3 times 2a1 plus 5d, and also from 1 we have 2 times 2a1 plus 7d. Then the 2 must be equal because S6 here must be equal to S6 in here, and then from this equality 3 times 2a1 means it is 6a1 plus 3 times 5d means it is 15d is equal to, again 2 times 2a1 means it is 4a1 plus 2 times 7d gives us 14d, and then collect a1 on one side and d on the other side, which means bring 4a1 to the right, to the left, it becomes minus 4a1, and then here we have 14d, which is 14d. Then move 15 to the right, and here it is positive, and then it must be negative after we move to the right, and then 6a1 minus 4a1 means it is 2a1 is equal to 14d minus 15d means it is simply minus 1d, which is written as minus d. And this can also be, if we multiply both sides by minus, then our d is equal to minus 2a1, and put this one somewhere here. Just call it 3, equation 3. The relationship between d and a1 is obtained from when? From which equation? From the equation we formulated here. From the statements, and combine this one with the sum of the first n terms, and therefore we get this one. The main point here is to answer or to check whether each of these multiple choices are true, each of this one is true or false, and we get d is equal to minus 2 times a1. And also now we used this one, and therefore what is left? We use a10. a10 is equal to 2 over a20 plus 23. Note that this a10 means with respect to, or in terms of the first term and the common difference, it is written as a1 the first term plus 9d the common difference, 9d, n minus 1, which is 9d. Our n is 10, then 9d. Similarly, a20 here can be written in terms of a1 and d as such. A20 means it is equal to the first term, which is a1 plus 19, n minus 1 means it is 19 times d, 19 times d, we call it 19 times d. And then now let us proceed here. Also from a10, which is given as such, we have a10, as we already seen, a1 plus 9d times 2 over 3. A20 means it is a1 plus 19d, and then plus 23. Now let us make this one linear. That means multiply both sides by 3 to make it linear. Then multiply this one by 3, this expression by 3 times a1 plus 9d, and then multiply the first part by 3, then 3 cancels 3 times 2 over 3 means it is simply 2, then put it 2 times a1 plus 19d, and multiply the same 3 by this one, because we multiply both sides by 3 up to 23, and therefore 23 becomes 69 when it is multiplied by 3. And now collect the terms that contains variables a1 and d on one side and the number on the other side. Let us collect the terms with a1 and again d to the left side. This means move 2a1 to the right, to the left, it becomes minus 3a1 minus 2a1, and move right to this 27d here, and move this one 38d to the left, it becomes minus 38d. Then what's left here? 69, the number itself, 69. Then 3a1 minus 2a1 gives us a1, and again 27d minus 38d gives us minus 11d, which is exactly equal to 69. Now it is time to use this one. D is equal to minus 2a1. We already obtained that one, and therefore since our d is equal to minus 2a1, then replace d or substitute minus 2a1 for d here, which becomes a1 minus 11 times, instead of writing d we say write minus 2a1 because d is equal to minus 2a1. Then right here, put it in bracket to separate the minus. Minus times minus, it is positive. 2 times 11, it is 22. Therefore a1 plus 22 a1 is equal to 69. The sum of these two gives us 23 a1, which is equal to 69, and then divide both sides by 23, which becomes a1 is equal to 69 over 23, and therefore a1 is equal to 3. Our a1 is equal to 3. Our a1 is equal to 3. Our a1 is equal to 3. And since our d is equal to minus 2a1, then our d should be what? Minus 2 times and a1 is 3, which is 3. Then minus 2 times 3 gives us minus 6. We obtain also minus 6. Now let us come back to, don't forget these two. The first term is 3 and the common difference is minus 6. Don't forget. And therefore here the one in choice A says the first term is 3, therefore it is true. This is true. And its common difference is minus 6. This is also true. Both are true. What about in C? Now either this one is false, not true, or this one is not true. That is what we know. And let us see how to find the n plus 1's term. Let us check whether the n plus 1's term is equal to 3 plus 6n. It is obvious already, since our common difference is minus 6, this must be 3 minus 6n. If that is also, if it is true. Now let us clean this area, please. Let us clean this area and let us write. What does this mean? What is the n plus 1's term in an arithmetic sequence? We know that the nth term an of an arithmetic sequence is given by, we have already seen this one in the definition of an arithmetic sequence. It is equal to a1 plus n minus 1 times the common difference d. This is the nth term. But what is the n plus 1's term? The n plus 1's term means the term which is next to the nth term. Next to the nth term. N plus 1's term. This one is the next term to an. This is also equal to, just replace n by n plus 1. a1 as it is, leave it a1 as it is, plus our n in this case is just replace n by n plus 1 here in bracket, n plus 1, and then we have also minus 1 here, minus 1 times d, this is d, call it d, and this is just call it bracket, suppose it is bracket. Then this thing becomes again a1, we have 1 minus 1, it is 0, therefore n plus 0 is n times d gives us nd, which is why I say since our d is minus, then this must be minus instead of plus. N times d, we have both a1 and d, and therefore the n's plus 1's term, which is written by n plus 1, becomes as such here. It is equal to our a1 is, we already obtained this one, we already get a1, which is 3, and our d is minus 6 times n becomes minus 6n, and therefore we conclude that this term is not true, and our question says which one of the following is not true, and therefore the answer is the one which is not true is C. The one which is not true is C. But suppose that this choice is in D, on D. Suppose this, interchange the two. Put this one, the sum of the first 12 term is minus 36 to C, to choice C, make it choice C, and this one, the n plus 1 term is 3 plus 6n to choice D. Interchange the two, please. Suppose it is interchanged. How can you check this one? The sum of the first 12 terms is minus 36. Whether this is true or not, how do you know? Now let us see. How do you know whether that is true or not? We have already here the sum Sn is equal to n over 2 2a1 plus n minus 1, and then replace n by 12 because the 12 term it says the 12th term, and therefore our n is 12. 12 divided by what? It is 2 divided by 2, and then multiplied by, we have already a1 which is 3. 2 times 3 gives us 6, and 12 minus 1 is 11, and multiplied by our common difference, we already obtained this is minus 6, then minus 6, put it minus 6, and then now perform this operation. Here we have 11 times minus 6. 12 divided by 2 means it is 6. Here put in bracket again. 11 times minus 6 means minus 66. Therefore 6 minus 66. What is the result? Now perform this operation in bracket. It becomes minus 60. 6. Let me put it like this one, please. Here this is 66. It doesn't look like 66. It doesn't look like 6, and therefore we have to just rewrite that 6. 6 times, we have the operation inside the bracket gives us 6 minus 66 means minus 60. 60 minus 60. Then multiply 6 by 6, it is minus 36, and simply write like this one. 6 times minus 60 means 360, and therefore it is true. Therefore the one which is false is this one, which is not true. Not true means it is false. Which is not true is this one. That is the end of this video, and next time in part 4 we will see the remaining questions that are supposed to appear on the examination, and which are considered to be hard from this unit, for about series and the sequence. Now this question number 8 is considered to be question with 2 stars, which means it is difficult. Actually it is difficult or difficult question that can be prepared from unit 1, and then that is the end. Please don't forget to subscribe to get the next part, to be notified about the next video. Please subscribe and hit the notification and like and share. And also, if the way I am presenting this lesson is have some defect, please tell me, let me know, and let me change the way to present. That's it. Goodbye, please. See you next time.